Hello, all of you. I hope you're doing good. My name is Aditya, and today I'll be talking about the Minimax algorithm. So let's get started. We'll start with the introduction of the Minimax algorithm. The Minimax algorithm is a recursive or backtracking algorithm which is used in decision making and game theory. It provides an optimal move for the player, assuming that opponent is also playing optimally. The Minimax algorithm uses recursion to search through the game tree. The Min-Max algorithm is mostly used for playing games in AI such as chess, checkers, tic-tac-toe, and various two-players games. These algorithm computes the minimax decision for the current state. Let's understand the Minimax algorithm. So in this algorithm, two-player plays the game. One is called max and the other is called min. Both the players fight it as the opponent player gets the minimum benefit while the other gets the maximum benefit. Both players of the game are opponent of each other, where max will select the maximized value and min will select the minimized value. The Minimax algorithm performs a deep first search algorithm for the exploration of the game tree. The Minimax algorithm proceeds all the way down to the terminal node of the tree, then backtracks the tree as the recursion. So let us look into how the min-max algorithm actually works. So the working of the min-max algorithm can be easily described using an example. Below, we'll be taking an example of game tree, which is representing the two-player game. In this example, there are two players. One is called the maximizer and the other is called minimizer. Maximizer will try to get the maximum possible score and minimizer will try to get the minimum possible score. The algorithm applies DFS. So in the game tree, we have to go all the way through the lead. So to reach the terminal nodes. At the terminal node, the terminal values are given. So we'll compare those values and backtrack the tree until the initial state occurs, following other main steps involved in solving the two-player game. So as you can see in the diagram depicted here, like if A is being played by max, then BC chance will go to the minimizer, again the maximizer, and then as you can see, the terminal nodes is stated there. So the all those terminal nodes have some value, and since it's the chance of minimizer, the maximum value from the terminal node will be selected. As you can see in the step 2, we have selected and given the value to nodes D, E, F, G respectively by choosing among H, I, J, K, L, M, N, O, and all. In the first step, the algorithm generates the entire game tree and apply the utility function to get the utility value for the terminal states in the box below tree diagram. Let's take the initial state of the tree. Suppose maximizer takes first turn, which has worst case initial value equal to minus infinity, and minimizer will take the next turn, which has the worst case initial value positive infinity. Now, first we find the utility value for the maximizer. Its initial value is minus infinity. So, we will compare each value in terminal state with value of maximizer and determine the higher node value. It will find the maximum among the all. So, like for node D, max of minus 1 or minus infinity is max of minus 1 to 4, that is 4. Max of 2 comma minus infinity, 2 comma 6, 6, and respectively, we obtain the following values. Moving forward, proceeding to step 3, as you know that we have obtained the value of D, E, F, G node. So now it's the turn of the minimizer. So nodes B and C will be assigned the minimum values among node D, E, and F, G. Okay. So in the next step, it's a turn for minimizer. So it will compare all nodes value with positive infinity and will find the third layer node value. For node B is equal to min of 4, 6 is equal to 4, and for node C minimum of -3, 7, that is -3. So after this, it's the turn for maximizer, and it will again choose the maximum of all nodes value and find the maximum value for the root node. In this game tree, there are only 4 layers, hence we reach immediately to the root node. But in real game, there will be more than 4 layers, obviously. So for node A, we'll find the maximum of 4 and -3, and hence we'll get 4. That was the complete workflow of the min-max 2-player game. Now, let us look at some properties of the Minimax algorithm. So, the Minimax algorithm is complete. It will definitely find a solution if there exists in the finite search tree. The Minimax algorithm is optimal if both opponents are playing optimally only. As it performs DFS for the game tree, the time complexity of the min-max algorithm is big O of B exponential in, where B is the branching factor of the game tree and M is the maximum depth of the tree. Space complexity of the min-max algorithm is almost similar to the DFS, which is big O B of F, B into F. Some of the limitations of the Minimax algorithm is the main drawback of the Minimax algorithm is that it generally gets slow for complex games such as chess, Go, and all. These types of game has a huge branching factor, and the player has a lot of choices to decide. This limitation of the min-max algorithm can be improved from alpha-beta pruning. So in conclusion, I would like to conclude by saying the min-max algorithm finds application in decision-making process across diverse fields. Its principles are leveraged in scenarios requiring optimal choices in the face of completing interest, contributing to the fields like AI, finance, and logistics. As technology advances, and with the advent of machine learning and more sophisticated algorithms, the min-max algorithm remains a foundational concept in the broader landscape of decision-making strategy. Its legacy endures as a testament to the fundamental principles of strategic thinking and optimization in the face of uncertainty. With this, I've concluded and thank you. Please like, share, and stay tuned for any upcoming videos.